So in this video, we are going to talk about our section 7.3, something known as partial fraction decomposition. So basically what this means is that we are going to break fractions apart. So before we break fractions apart, let's actually go backwards and how do we bring fractions together? Okay, so if we take a look at one of our first examples. So if I say that you have 3 over x minus 1, and I want to add that with -1 and x minus 3, okay? So in order to add fractions together, we need to have a common denominator. So I notice that the first fraction has the denominator of x minus 1, so it's missing the x minus 3. So we can go ahead and we can multiply top and bottom by a fraction of 1 without changing the value, and now the denominator has two binomials. I can do the same thing on the second set of fractions, but just again with the opposite binomial, so x minus 1, x minus 1. So my numerator in my first fraction becomes 3x minus 9, and then x minus 3, x minus 1. Over here, I have a negative x and then a plus 1, because -1 times x gives me the negative x. -1 times -1 gives me a positive 1. And again, same denominator. Once they are exactly the same, we can add them together. So 3x and negative x gives me a lovely 2x, and -9 plus 1 gives me -8. And again, we can either leave it as binomials, right? Or what we could do is we could factor it out into x squared, or multiply it out, I should say, x squared minus 4x squared plus 3, and again, leaving them with the numerator 2x minus 8. So what we're going to do with partial fraction decomposition is we're going to work backwards. I'm going to give you this answer, and you need to find the numerators, right? We need to figure out what the two values are for both the fractions. And so it's definitely a little bit more of a process than when we multiply fractions together. So the first thing I did is I wrote out the steps for you guys. So here are the 6 steps. So the first step I call step 0, right, which is right here. What you want to do is you want to focus on if your numerator is larger than your denominator, right? So this would be something like x cubed plus whatever, and then x squared plus whatever. Or we could have potentially them be the same exponents in both the numerator and denominator, so maybe like x to the power of 4 and then x to the power of 4, right? So if you see something that looks like that, what we have to do is we kind of have to do step 0, kind of divide, and then we can continue to focus on our 6 steps. All right, so step number 1, we're going to factor only the denominator. Who cares about the numerator? Okay, so depending on what the denominator is, it's going to factor into at least 2 things, right? And so we're going to express them as 2 or more fractions, and we're going to put placeholders there. We'll just call them A and B, right? You can use whatever you want, but we want to try to avoid using the letter X as a placeholder since X is usually in our expression, okay? We're going to get rid of our fractions. We're going to multiply both sides by our LCD. Again, LCD stands for the lowest common denominator. And then we'll set up our system and we'll solve our system. We'll substitute our answers back into our partial fraction. All right. So based on this information, right, let's figure out kind of what steps look like. And I'll walk through. So we're actually going to do the same exact example that I just did when I brought the 2 fractions together, but I'm going to break them apart. So I'm going to call this example number 1. So 2x minus 8 all over x squared minus 4x plus 3. Okay, so step number 1, what we want to do is we want to factor. So that's step number 1. All right, so factoring, we are going to figure out what 2 numbers multiply to 3 and add to -4, so in case we didn't know, and those numbers happen to be a -3 and a -1. We can put that into our area model, if this is how you like to factor, x squared goes in a corner and the positive 3 goes in the other corner. These values, -3 and -1, they will also go in opposite corners. So what goes into both x squared and -x? That would just be an x. And x times what gives you x squared? An x. X times what gives you -3x? So -3. And -3 times -1, in fact, gives me +3. So our two factors are going to be, actually I put this over here. So I'm going to say 2x minus 8 all over x minus 3 and x minus 1. So I have done step number 1. I have factored the denominator. Step number 2, we are going to express them as two or more fractions. Okay, so step number 2, put little 2 here. So this is where step number 2 comes into play. So for however many binomials we had, that's how many fractions we need. So I have 2 binomials. So I'm going to put x minus 3 in one, and I will put x minus 1 in the other one. And I need to put a placeholder. So I'm going to say that this is A, and then this is B. All right, so once we put our placeholders A and B, the next step is step number 3. We're going to multiply by the LCD. Okay, so step number 3 is going to look something like this. So this will be 2/3. We'll put them together. Okay, so I'm going to multiply both sides by my binomial, x minus 1, x minus 3. So x minus 1, x minus 3. Doesn't matter how we write it. Okay, so what that looks like, everything on the left-hand side is going to disappear. So we'll just be left with 2x minus 8. And then on the right-hand side, we'll still be left with our placeholder A. But if I multiply the first fraction by these two binomials, the x minus 3's will go away. So you'll just be left with x minus 1. And then with my b, the other one will disappear. So you'll just be left with x minus 3. All right, so so again, this is kind of step number 3 still. All right, now before I can set up a system, I have to kind of rework the right-hand side. So I'm going to go ahead, I'm going to distribute the a inside. So I'm going to get ax minus a, and I'm going to say bx minus 3b. Okay, I want to kind of move things around so that way my x's are with my x's and my things that don't have x's are with each other. So I'm just going to move things, so ax plus bx, and then minus a minus 3b. Now we have to remember that a and b are placeholders, okay, for integers or fractions of some sort. So we actually only care about the coefficients to our variables. We only care really about the a and the b. So I'm actually going to factor out the x. I'm just going to say a plus b. And so really that becomes a coefficient. We don't have anything to factor out. We don't have a variable to factor out with my second problem, or the second set of numbers. So I can go ahead and just leave it alone. So if you think about this, right, the 2 in front of your x is a coefficient. And that's like saying the a plus b is also a coefficient. So that's going to be one of our systems. So I'm going to say 2 is equal to a plus b. Now for the other one, right? So let's change it to green. So I have -8. So that's just a constant. Here I have no variable, so it's just a constant. So this becomes -8 is equal to -a minus 3b. So this is step number 4 right here. Okay. So once I've come up with my 2 equations or 3 equations, depending on what we have, what I can do is I can manipulate either one of the equations in order to cancel out our variable. So I want to solve for my answer. So again, I'm going to manipulate it. So I'm going to say that step 5 is kind of right over here. So I don't actually have to manipulate it because my a's are opposites of each other. So this will just give me negative 6 is equal to, my a's cancel out, negative 2b, so b is equal to 3. Once I find b, I can plug it into either one of the equations, and I get my a value, negative 1. All right, final step, step number 6. You are going to now replace, it says, substitute answers back into the partial fraction. So this is our partial fraction right here. So our numerator was a, so that would be a negative 1. My denominator was x minus 3. And then for b, my numerator was 3, and my denominator is x minus 1. So this should have been the same answer that we originally started off with, right? So 3 went with the x minus 1, the negative 1 went with the x minus 3. And that's it. That is my answer. You will always get an answer for A and B. If you don't, that means you did something wrong. Okay, so let's try example number 2. If you want to try this on your own and pause the video and see if you get the answer right, please go right ahead. I won't be writing out as many steps or showing you that this is step 1, this is step 2. Okay. All right, so first thing I want to do is I want to factor. So that is going to factor using my area model. So 2x squared goes in one corner, negative 2, negative 4 and 3. So my two numbers happen to be 4 and negative 1. So this becomes 4x and negative x. So I'm going to put a 2x here, and this will just be an x, negative 1, positive 2. So this becomes 5x minus 10 all over x plus 2, 2x minus 1. I'll put placeholders. So a, and this will be my first binomial, and then my second binomial with another placeholder, b. All right, so two binomials, got to get rid of my fraction. So how do I get rid of my fraction? Go ahead and I'll multiply right side and left side by my two binomials. And same thing on this side, same two binomials. So my 5x minus 10 will be the only thing left over here. And then over on this side, we have the a, that's going to be multiplied by the 2x minus 1. And then we have our b, which will be multiplied by our x plus 2. Distribute, so 2ax minus a plus bx plus 2b. Again, kind of move things around if you would like to do that. If you don't find that helpful, you can always skip these little steps. So 2a plus b, and then negative a plus 2b. Again, 5x minus 10. All right. Again, 5 is the coefficient to x, and notice that 2a plus b is the coefficient to that side of the x. So those go together. Negative 10 is going to go with that guy right there. So what is that going to look like? 5 is equal to 2a plus b. Negative 10 is equal to negative a plus 2b. Okay. So depending on what variable you want to eliminate, I think I am going to eliminate the a's. So I'm going to multiply everything by 2. So that is going to keep my numerator, or my first equation the same, and it will change my second one to this. Negative 20 is equal to negative 2a plus 4b. Add them up, get negative 15, those cancel out. I'm left with 5b, so b is equal to negative 3. Once I get that, plug it back in. I'll plug it into the top equation. So 2a plus negative 3, add 3 to both sides. 8 is equal to 2a, so a is equal to 4. All right, so my problem will be 4x plus 2, and then negative 3, 2x minus 1. Now, there is a second way that we could write this. I mean, we have a negative. You don't have to keep the negative in the numerator. If you wanted to bring it down, you can. You can just change the addition sign to a subtraction sign. So it will look something like that. Again, either way, it's perfectly fine. And again, the order doesn't matter. If you tried this on your own and you put 2x minus 1 first, again, the negative 3 over 2x minus 1 would just be written first in your problem. Again, order does not matter. Okay. Now, for example number 3, this one's going to be a little bit different because it's still going to be a two-variable system, but notice that now I only have one thing in my numerator. For example number 1 and example number 2, I had two things. Okay. So setting up our system is going to be a little bit different. All right, so I can still go through all of the steps. My numerator is not larger than my denominator. I can still factor this. Now, when you have an a value, right, that's equal to 1, whatever two numbers that multiply to negative 6 and add to 1, that can just immediately go into your two binomials. So x plus 3 and x minus 2. We still have two binomials. So that means I need two fractions. And again, I'm going to put placeholders here, A and B. Okay. I need to clear my fractions, so let's clear it. So multiply by x plus 3 and x minus 2 to both sides. Again, so far, nothing new and different. This is still the same thing, so 5 is equal to, and then we'll go back to our placeholder, so A, and then our x minus 2. Second placeholder B is going to be multiplied by x plus 3. Okay, so this gives you ax minus 2a, and then bx plus 3b. Collect your like terms. So I'll move everything kind of around, equal to, and then I'll factor out the x. And I don't need to factor anything out here. So I'm done. Okay, so notice that on the previous two problems, okay, when I got to this step, right, and I was able to factor out the x, I had something on the other side that had an x. Again, same thing here. When I got to this point right here, the a plus b, I had something on the other side, I had an x. Here, I don't have anything with the x. So what could I put there and not really affect my 5? And the answer is a 0x. If I put a 0x there, 0 plus 5, that still gives me my same value. Okay, so I want to, so I only really care about the 0. Right, so again, 0 is going to be my coefficient to my a plus b. So that is new and different. The 5 is your constant, and again, this has no variable, so it's going to go together. So I still need to come up with two equations, and that's how I'm going to come up with my two equations. So if I was missing a constant, my constant would be equal to 0. So a plus b, and then here would be 5 is equal to negative 2a plus 3b. Again, how you want to go about solve this is up to you. Okay, let's do substitution. So I'm going to take the top equation, and I'm going to say that a is equal to negative b, right? So that means I'm going to substitute everywhere I see an a. I'm going to substitute in a negative b. So I'm going to say 5 is equal to negative 2 times negative b plus 3b. So 2b plus 3b will give me 5b. So my b is equal to 1. Once I get that, 0 is equal to a plus 1. Move the 1 over to the other side. So that means my a is equal to -1. And that's it. So my a was -1, and I have x plus 3. And over here, I had a +1 and x minus 2. So yeah, same idea. You're still going to get values. You just have to now set the equation equal to 0 instead of an actual number. All right. So let's look at equation number 4. So equation number 4 is also a little bit different. Okay. So I'm going to say that it's 2x minus 3, and my denominator, x minus 1 squared. So what's different about this one is that it's not written as a trinomial, so to speak. It's written as a binomial squared. So we don't have to factor. Step number 1 is done. So what do we actually do? Well, I'm still going to write this out. I'm going to write it out as x minus 1 times x minus 1. There's still two binomials. Okay, so that means that I should have two fractions. But the problem is, right, if I look at example 3, I took my x plus 3 and I took my x minus 1, and they were two separate fractions. They're different denominators. I can't add them together right away. I'd have to manipulate it. Same thing with example 2, x plus 2 and 2x minus 1. They're two different denominators. Here, if I take x minus 1 and x minus 1, they're not different denominators. I could add these two fractions together right away. But the problem is, if I added these two fractions together right away, my denominator is not going to give me this. Okay? So the question is, how do I manipulate my fractions so they're different, but yet still have x minus 1 in both of the fractions? So if you want to pause and think about it, you can. If not, here's your answer. In order for them to be the same, but a little bit different, we're going to keep x minus 1 the same in the first fraction, but I'm going to make the second fraction squared because that's what I want it to be eventually. I want it to be x minus 1 to the power of 2. Okay, so anytime you see exponents like that, you can write it out twice, but then just start going from the lowest degree, which is 1, to your highest degree that's given to you. So that means that you have an A and you have a B as a placeholder. Once you do that, everything else should be smooth sailing. You should be doing exactly what we did before. So we're going to go ahead and again, notice that I'm not multiplying it by x minus 1 squared and x minus 1. Again, it's your lowest common denominator. So I'll always multiply it by whatever I write it as on the left-hand side. It's kind of my go-to. Well, I just said squared, but I wrote a squared. Didn't mean to do that. Okay, so my left-hand side just becomes 2x minus 3. And my right-hand side becomes an A. And then this becomes x minus 1, because one of the x minuses do cancel away. And then notice for my b, the x minus 2, again, this is like saying x minus 1 times x minus 1. Both of them cancel away, so there's nothing else I need to put with a b. I'm done. So I'm going to distribute. I'm going to get ax minus a plus b. Great news. I don't need to rearrange things, which is nice. Okay. I also don't need to really factor anything out because there's only one thing that has an x with it. So here is my coefficients to my x, so 2 and a. And then my coefficient, or my constant, is -3 and -a plus b. So my two equations, 2 is equal to a, -3 is equal to -a plus b. Well, great news, right? For us, at least. Here, I already know what one of my answers is. So I'm just going to go ahead and plop that right in here. So -3 is equal to -2 plus b. Add 2 to both sides. I get b is equal to -1. Once I get my answers, I'm going to plug them back in to my equation. My a was 2, my b was -1. And that's all you have to do. All right. So I think we kind of have exhausted two variable systems. Let me show you let me show you an example of a three variable system. It's the same idea, you're just gonna have three fractions. All right, so this will be our final example. Example number 5. So we are given negative 6x squared plus 11x plus 15, and then the denominator, x cubed, minus 2x squared minus 15x. Okay. So what I notice is that in my denominator, again, I don't care about my numerator, I only care about my denominator, is the first thing is that there's an x in everything. So I can factor out my GCF, which is perfect. And then my x squared minus 2x minus 15 is going to factor into x minus 5 and x plus 3. So my numerator stays exactly the same, and my denominator will become this. Again, I have three, excuse me, I have three things in my denominator. They're all different, which is nice. I don't have to deal with things to the power. So they are all going to be separated to three fractions. So x, x minus 5, and x plus 3. And then my placeholders will be a, b, and c. Okay. So when I multiply, okay, please be aware, right, that you now have three things being multiplied to all your fractions. Okay. And again, I will color coordinate this a little bit better on this one since it's a 3 variable and it's new. Okay. So let's start with the left-hand side. That's the easiest side. The negative 6x squared plus 11x plus 15, nothing changes. Okay. So then I have my placeholder. I have a, and I'm going to multiply that by my three terms. Now, my a has an x attached to it, so my x goes away. So I'll actually just be left with x minus 5 and x plus 3. All right, put a little plus sign, and then my b value. Okay, now my b, again, has a binomial x minus 5, so that means that it has the other two terms, which is just an x and an x plus 3. Right? Again, put a little addition sign. And our third term, which is c. And again, the c has an x plus 3, so it is missing the x and an x minus 5. Now, you could write x minus 5 and x plus 3. We could just easily write this as just x squared minus 2x minus 15, right? Make our life a little bit easier, right? And then keep everything else exactly the same. So put a little addition sign, put a little addition sign there before I change my color. So this becomes b, and then x plus 3, and then c, and then x times x minus 5. Okay, so now that we kind of understand what we're doing, I'm probably going to drop the colors, equal sign. So the a is going to be distributed to everything, so I'm going to be left with an ax squared minus 2ax minus 15a, so that's my first one. Now, what's great about having a monomial, b times x is just bx, so that means bx times x gives me bx squared, and then plus 3bx. Same thing over here, cx times x gives me cx squared minus 5cx. Again, especially with three variables, I tend to rewrite things. So ax squared, bx squared plus cx squared, and then minus 2ax plus 3bx minus 5cx, and finally minus 15a. So now that I've gotten in this order, I'm going to factor out the x squareds. So this becomes a plus b plus c. Please be aware of your coefficients of positives and negatives, right? going to factor out the x here, so it becomes negative 2a plus 3b minus 5c. Again, the only things you're factoring out are the x's. And then finally, negative 15a. On the other side, I am going to rewrite this problem out one more time. Let's see that. Okay, so we do have 3 terms on the left-hand side. So negative 6 is a coefficient, and so we're going to set that a plus b plus c equal to that one. Okay. I see 11 as a coefficient to x, so that means I'm going to set that equal to 11. And then last but not least, we are going to set 15 equal to that guy, negative 15a. So here are my equations. So negative 6 is equal to a plus b plus c. I have 11 is equal to negative 2a plus 3b minus 5c. And then I have 15 is equal to negative 15a. So there are my 3 equations. Okay. Now my bottom equation, right, is going to be the easiest. I can just easily divide both sides by negative 15, and I'm going to get a is equal to negative 1. That's the first thing I can do. Now, the second thing I can do, right, is I can look at my first equation and I can look at my second equation, and I can manipulate them, right? I can try to get rid of a variable, either the b or the c first, or I can plug in negative 1. So I'm going to plug in negative 1 first and see what happens. So negative 6 is equal to negative 1 plus b plus c. So my first equation will be negative 5 is equal to b plus c. I'll do the same thing with the second one. So 11 is equal to negative 2 times negative 1 plus 3b minus 5c. Negative and negative turn positive. That becomes a 2. So that means that this becomes a 9. And then 3b minus 5c. Again, these are kind of like brand new equations. Call that equation number 4, call that equation number 5. Now it's just to determine what variable you want to cancel. I think I am going to eliminate my b's. So I'm going to multiply both sides by negative 3. And that would give me a positive 15, negative 3b minus 3c. So that will give me a 24 is equal to negative 8c. So c is equal to negative 3. Once I find my c value, I can plug it in, find my b value. So I already know that negative 5 is equal to b plus negative 3. So that means my b is equal to 2. So again, I have my a, I got my c, I got my b. So my answer should be a, negative 1, all over x, plus b, negative 2, all over x minus 5, plus c, negative 3, over x plus 3. This is our final answer. Okay, so all 3 variable systems kind of look exactly like this. One of the equations will be a little bit easier than the other.